Hello, my name is Levente, and in 2021 I started Upcycled Plastics. During my 18-month business venture, I developed and built a production line to transform used plastic into a range of 100% recycled products. Along my journey, I placed second in the Young Enterprise Scheme competition, recycled over 600 kilograms of plastic, and worked with some of New Zealand's leading companies to create a small mark in one of the world's fastest growing environmental issues. Now, there is a massive amount to cover, so I've created 4 main videos. This 3-part series is about my journey, which covers my learning, successes, failures, the problems I faced, and how I went about solving them. Whereas the 4th video is a detailed look into how I built all the final production equipment, and to best tell my story, I need to start at the beginning. In 2021, I took a semester of business at my high school, where I came up with the idea of creating and selling personalised letter stands. The original idea was inspired by this 3D printed version I'd made as a gift for my mother. To gauge people's interest in this product, I created various designs in CAD and sent out a survey. The feedback I received was exceptionally positive, with 240 responses. This then gave me the confidence to pursue the idea further. To produce the letter stands, I thought of using 3D printing like I did here, and in hindsight that would have been by far the easiest approach, especially considering it was for a semester of business. However, after completing my 2-year journey building RA3, I really wanted to pursue something bigger. Something that incorporated sustainability, innovation, engineering, and business, as these are all big passions of mine. So I gave my business a name and set myself a simple goal: to recycle as much plastic as I possibly could and to grow it as big as I could. To turn this concept into a marketable product, I carefully considered sustainability, manufacturing, usability, and visual appeal. I chose to make the letters from recycled plastic and stands from reclaimed pallet wood. To secure the letters, I used a friction groove design, and after extensive surveying, I decided to offer letters in 2 different sizes: 40mm and 60mm. With a clear vision, I explored various manufacturing methods to produce the letters and determined that CNC machining them from a plastic sheet would be the most viable option. However, before I could proceed much further, I had to decide on the right plastic to use. And after considering the following criteria, high density polyethylene, also known as HDPE, appeared to be the most suitable. However, to know for sure, I melted down a couple of HDPE milk bottles into a sample and tried cutting it with a laser cutter and CNC router, as I had access to these tools through my school. The laser just burnt the plastic, however the router cut it with ease whilst providing a pretty good finish. Therefore, my next step was learning how to properly use the CNC router and Fusion's CAM software. And after a bit of trial and error, I was able to cut the full alphabet from a scrap piece of MDF board. Feeling confident in my testing and research, I was convinced that a viable market existed for my recycled plastic letter stands and that their production was feasible if I could manufacture the plastic sheets needed for the letters, which brings me to the next challenge. At the hobbyist level, the most common method for creating recycled plastic sheets involves heating the plastic and pressing it into a mold to cool. For instance, the YouTube channel Precious Plastics employs a thin metal mold positioned between 2 heated plates, which melt and compress the plastic. Another common approach used by the likes of Brothers Make involves melting the plastic separately using a heat source like a sandwich press, and then transferring it into a mold for compression and cooling. While both methods are effective, I believed a hybrid approach between the 2 would best suit my needs and budget. The easily customizable wooden molds by Brothers Make appealed to me as it was a low-cost alternative to using metal, and at the time I wasn't even sure about the size and thickness of plastic sheet I would ultimately need, or what other extrusions I might want to make. However, I knew that I needed a powerful machine that could quickly heat large quantities of plastic, and a sandwich press wouldn't be sufficient. This led me to design my own custom machine using a similar heating system to the one in the Precious Plastics version, and here is a quick build montage. as I mentioned, if you want to see in detail how I built this machine and other equipment, you can check out my other video linked below. But to briefly explain how it works, there are two heater plates. The bottom one has a lip to contain the plastic, and the top plate is moved using a scissor jack. This ensures pressure can be applied to the plastic as it shrinks, which helps remove air bubbles and speeds up melting time. And since the most important part of any project is the journey, here's 30 seconds of everything that went wrong. Initially I tried adding a linear slider, but that kept jamming. Then I tried a wheel runner design, but this failed. Then for a lifting mechanism I tried a bottle jack with retracting springs, however the plate was too heavy. So finally I settled on a scissor jack with no guides, then I rewired, remade, retried a few more times before I got most of it working. With the ability to melt plastic, I was now ready to start building molds. For my first attempt I created one measuring 500 by 500 mil, using a combination of melamine for all the contacting surfaces, then pine to reinforce the edges. Additionally, I needed a hydraulic press to compact the plastic inside the mold. And since off-the-shelf products were expensive, I decided to build my own by fabricating a steel frame and using the leftover bottle jack from the press machine. During the same period, I was actively searching for sources of used HDPE plastic, preferably in a single colour. And one day, while heading to work, I spotted a stack of white HDPE milk bottles outside a cafe, and the manager let me take them home. I then washed the bottles and removed the labels. I continued this on a daily basis, and after about the 500th bottle, I was getting a little sick of it. So I built a wash station using irrigation fittings, which allowed me to clean 2 bottles at once. To activate it, I used the solenoid valve from a broken washing machine and a basic foot pedal, and this worked surprisingly well. My next challenge was finding a way to shred the plastic. Since I didn't want to spend much, I decided to buy a second-hand mulcher. At first it didn't cut the plastic, but after some experimentation I found if the bottles were flattened and folded to increase the material's thickness, the mulcher would cut the plastic into small strips. 1 month prior I had signed up for the Riccarton market to sell my products and gather customer feedback. This market was important as it was the biggest in my area and it was a really valuable opportunity to gather insight. However, I kind of forgot about it and left myself 1 week. Therefore, I decided to take pre-orders instead of having build your own letter stands for sale on the day as I had originally planned. This reduced the immediate workload, but I still needed to quickly create a few display models. And this should have been easy as I had just finished building all my equipment. However, at some point the temperature probe on the heating machine broke, which meant it surged well beyond 400 degrees and exceeded safe operating levels. To work around this issue, I resorted to using the barbecue as a heat source. However, this proved to be extremely challenging as I kept burning the plastic or not heating it enough. After approximately 8 hours, I finally obtained a usable batch, which I promptly placed inside the mold, and after waiting patiently for 12 hours, it turned out to be usable. The surface texture was very rough and uneven, so I tried running it through my school's thicknesser, removing 3 mil from each side, and this result was a significant improvement. Next, I used a CNC machine to cut out the letters, and I created stand bases from discarded pallet wood, which I sourced from a local factory. To secure the letters, I cut the slots using a table saw. And these were the final prototypes, just in time for the market. Lastly, I set up a stall with my signage and product. To my surprise, I got 10 orders and a lot of valuable product feedback. And to sum it up, people love the sustainability factor, design, price, and the overall idea. These 3D printed ornaments, which were a last minute idea, turned out to be very popular as well. Now, you might be confused as to how I got this beautiful grey marbling from white milk bottles. And at first I was too. It turns out Anchor milk bottles are comprised of 3 layers. A white interior and exterior with a black middle layer to keep out light and to preserve the milk. And this meant when the plastic mixes, it turns grey and creates this pattern. With that knowledge aside, the next step was addressing all my production issues and fulfilling the 10 orders I'd received. Which I would quickly discover is easier said than done, as there were a lot of variables I still needed to fine tune, like quantity of plastic each sheet needs, mold release, cooling time, optimal plastic temperatures, and heating durations. And what initially seemed like a straightforward task turned into a month of experimentation that involved conducting dozens of tests on 4 different mold designs. My first tests were conducted on the melamine mould I had made. However, because I didn't use enough mould release, the mould stuck together and I had to break it open. The next tests were conducted on a new melamine mould with a better form factor so the plastic sheets could fit through my school's thicknesser. However, from repetitive use, the melamine coating began to degrade. So I built a new mould that had a Teflon sheet interior. This worked really well and prevented sticking. However, the Teflon sheet was not very durable and quickly developed wrinkles which transferred into the plastic. Additionally, I faced constant issues where the plastic would cool before it could reach the corners of the mould, or the plastic would flow more to one side than the other, leading to incomplete or uneven sheets. To help address this, I experimented with different expansion gap sizes, which in theory allowed excess plastic to flow out. And whilst this helped, I still couldn't fully close the moulds or press a consistent sheet. Therefore, in my next attempt, I fitted the mould with aluminium plates and used a heat gun to preheat the interior. This significantly reduced the cooling rate of the plastic, which yielded a more consistent sheet, and I was able to finally fulfill my 10 orders I had promised. However, it was still far from production ready and there was a lot of work ahead of me. And if you're curious, these are the results I found worked best. I then took a break over Christmas, and when school resumed I was told about the Young Enterprise Scheme, which is New Zealand's largest business competition with over 1,000 teams entered in 2022. And the goal is to complete various challenges and paperwork to advance and remain in the competition. However, to win, teams must deliver multiple pitches to different panels of judges throughout the year, with only the highest scoring advancing to the next round. And obviously I entered, which meant I had just under 12 months to make something out of my plastics project.